What is going on, guys? This is Chris at Virtual Trading. Hope you guys are having a nice day today. In this video, we're going to look at a new algorithmic trading system we created here. It's an automated system for a buddy of ours, a trading buddy, who requested something. So if you guys are interested in learning how to build automated trading systems in Sierra Chart, or if you're just curious about how I became a coder in 2 months with zero coding experience, stick around because that's what we're going to show in this video. I'm going to show you guys a super cool automatic profit target setter that we're going to show right now. Stick around. If you enjoyed this content, press the first link in the description. That will help out the channel, support the channel if you enjoy the content. Let's get to it. Okay, so on the right side of my screen, there is a chart that is currently replaying, and this chart belongs to a trader named Ryan, and right now this chart is replaying the market on this date at this time, and that is what we are going to use to show the demonstration. So I will move this to the other side of the screen for now. So on this chart right here, this is currently a chart that is set to a time frame of 30 seconds, meaning that each bar on this chart is a 30-second time frame bar. Now, if we look at the chart, you can see there are a number of lines here or levels, and what the trader requested was when they enter a trade, they tend to enter trades with a fixed quantity of contracts. They're trading futures. In this case, it's the E-mini S&P 500 futures or the micros as well. They enter the trade with a fixed position, and they want their targets to automatically appear at set values that they have on their chart. And these values are like VWAP, standard deviations, or Bollinger Bands, or whatever they have going on here. So what the study does is it checks for how many contracts are in the position, and it will submit the targets at the correct prices. So I'll show you now how the study works. I'm first going to bring over the trade window for the chart, and I will show you that if I go to the targets tab, there are no targets configured right here. There is only an attached stop of 24 ticks here, and there are no targets configured when entering a position on this chart. So I'll just get rid of that for now, and I'll bring it back there. Okay, so now I'm going to enter into a trade of 3 contracts. So I'm going to change the trade window quantity at the top left of my chart to 3. Now I'm going to enter a limit buy order here. And if this order gets filled, you will see the targets appear. So take a look. Okay, the order has been filled. Now take a look at where the targets have populated themselves. The first target has appeared right here at the first level. Then the second level is right here where this little shaded line is right there, you can see. And then the third target has appeared up there all the way at this line right here. So basically what the study does is it finds the closest levels on the top side and on the bottom side, and it will automatically set the targets to those prices. And it will, of course, do that for the number of contracts that are in the position. I will do another demonstration. So let's say we just fill this order and then, drag up our stop to get filled again.
Order has been filled.
Okay, now I'll do the same for a short position. So I will enter into a short position of 5 contracts. Currently, the study only supports a maximum position quantity of 5, but I can program it to do as many as I wanted. So I'll set it to 5, and this time we're going to enter into a short position. So I'll enter a limit sell order there on the book, and I'll just kind of chase the market down. There we go. Now we're short 5 contracts. Take a look at where the targets appeared. We have 5 targets that have been entered into the market. The first one is at this level, next one is here, next one is here, and so on and so forth. Okay, and that is basically what this study does. So if you find this cool, well, let me know in the comments. If you want to see how I made it, I'm going to show the code now, showing everything and how it all works together. So stay tuned for that. All right, so I am going to exit this trade currently just by submitting an order to get out. And on this particular chart, we do have it enabled that it will cancel any orders when the position is flatted. So that's the one thing. On the chart itself, the study is here. It's called Ryan Auto Targets. And if we do look at this study, it has a 0 millisecond calculation time. It is basically a super lightweight study. It's not requiring any processing power, even though it is making reference to around 14 different study subgraphs that are already on our chart. And that is pretty much it. This study has no subgraphs, as you can see right here. And it looks basic. It looks like there's nothing going on. But if I show you guys the code, there's actually over 1,000 lines of code here that were written for this particular study. There's 1,200 and something. Most of them are commented out. Well, some of them are anyways. So let's go ahead and look at what's going on. So at the top of the study, there are some defaults that are set here for trading. that are not really important. There is an input. This input is being used to turn on the condition for the target orders to be sent. If you guys are familiar with the other algo I shared with you guys, this is something similar. Basically, so there's a button. Basically, it's this button right here on the top right of my chart. It's actually configured to be ACS button number 1 or Advanced Custom Study button 1. When that button is pressed in on, that will allow the targets to be sent. If I do not have that button on and I enter into a trade, you can see that now there are no targets, of course, okay? So I'll show you how that works. I'll just get out of this trade. Let's go back to the code. We can take a look here. We have a whole bunch of persistent floating values that we saved to memory, that we needed to save to memory because we're making reference to all of these different study subgraphs. And then what we're doing later in the code is we are iterating through this array. We created an array using these values, and we're iterating through them in 2 different ways. We're iterating through them up and we're iterating through them down based on the reference of the last traded price of where the current market is. And we are setting those values to be in order of which ones are closest to the top side, second closest top side, third closest top side, etc. So that's what these are right here: value 0 up, value 1 up, value 2 up, etc. And then we're doing the same thing when we're iterating down. So basically what this is doing is it's iterating through all of these values, and it is finding, okay, that one is closest on the bottom side, that one is the second closest on the bottom side, third closest on the bottom side, etc. And then these values are being used to put our orders at the correct prices, right? So it sounds pretty simple when I said it that way, but there's actually a few things we had to watch out for as well, like certain logic that I had to think about when implementing the order structures, which I'll try and show you guys. So we also have some position data and last price data that we are also saving to memory here. So we're saving what is our current position size here, and we're saving that to memory. We're also saving the average price because the average price is being used to calculate if the nearest line, top or bottom, is within a certain range of our average price. We're actually going to send the target at the next level instead, because we don't want to have targets that are like 3 ticks wide or whatever, okay, for this particular market. And then the next things that we're saving into persistent memory are our order IDs, and we're using these to, you can use these to do anything, cancel the orders. You can use these to check if the order is live, then it goes ahead and executes something you want. You can also use it to cancel orders or modify them. All right, let's go on here. We'll try to get through this pretty fast. So chart trade mode needs to be on for order management to take place. Okay, that's just, you know, a precautionary thing right here. Then we have our code for the ACS button. So basically these lines right here are responsible for the Advanced Custom Study button being an on-off button. And when this button is pressed, what it does is it just resets the order IDs in memory to 0, just for safety, just in case there was any kind of value lying around in the code and that we don't want that. But anyways, this is not really totally necessary. It's just a safety step. Okay. Next thing we're doing is we're getting position data using this CR chart function. We start with this s_sc position data structure, sc.getTradePosition of position data. This function is getting all of the necessary position data, and then we can use the various members of the position data structure to get various data points. So in this case, what we're getting is the position quantity, we're getting the prior position quantity, and we're also getting the average price. And we're setting all 3 of those values to persistent memory to be used later in the code. All right, next thing we are doing is getting the last traded price. So it's saved in persistent memory under variable named last price is equal to sc.getLastPrice for trading. That's an sc function. The next thing we're doing before we have our for loop that is getting all of the arrays and study subgraph arrays for all of those levels on the chart is we're just specifying the size of the array to iterate through. In this case, I did a few tests with this. Right now I have it set to be the most efficient possible, which is basically setting the array to start on the current bar of the chart. So it's only iterating through the last bar of the chart. It's not going back and getting any chart bar data. We only actually need to get the current value that is being specified by the study subgraph from these studies, okay? And by the way, guys, I'm really not a programmer, so if you do see something in my code that looks off at times, feel free to let me know in the comments because I'm trying to get better, okay? That's it. And also, this is helpful for people that want to learn how to code with Sierra Chart, and it's also maybe helpful for people that, are experienced, that see that I'm doing this and are like, oh, cool, maybe you can improve on this a little bit. Guys, don't be shy, let me know and all that stuff, okay? So this function right here, get study array using ID. This is the function that we use to get the study subgraph arrays and then, do what we want with those. So in this case, what we're doing is we have these SC float arrays, which they're just basically names or structures in which we will save the study subgraph arrays here once we use these functions. So in this case, we're going to target the specific study IDs for the studies that are on this chart, okay? So if you're using a different chart where the study IDs are different, these values are all gonna have to be changed to go and target those study IDs from the studies that are on your chart. So even if you had the same exact studies on your chart, if they're not using the same study IDs and if the subgraphs on those studies are in different orders, then this will not be getting the correct value. So you need to check those one by one. In this case, we're using this function 14 times to get the subgraph arrays for each of those study subgraphs. And then what we're doing with them is we're putting them or saving them to memory right here. Now, this might not be totally necessary based upon how I organize the code later, but I saved them anyways just because I was going with the flow and I just, that's the way I did it. I don't want to waste too much time thinking about it. So they're all being saved to memory here under these names right here. So R underscore top band, R underscore bottom band, etc. R means reference. So we're making reference to those study subgraphs. Okay, then we have these message logging objects that I was basically using to check if I was getting all the correct values, and I was referencing that against the chart values window for our chart. So we go to window, chart values window, and in this window I was referencing the values I was printing to my message log with the values that are on the chart values window, just to make sure that they're all the correct values, because I don't want to be sending orders if I'm setting them at the wrong prices, right? So just make sure the prices are right first. Again, the add message to log feature here is probably one of the easiest ways to debug stuff and make sure you're getting the right values for certain things in Sierra Chart. Okay, so next we have our array that we created of floats. These are the study values that we got, or the study arrays. So type float, it's named array. It's an array. The reason it's an array is because we put these square brackets at the end of the name of it. The name for the array was set to be called array. Okay, so just to clear that up. Okay, so then we have all our values here that are in the array, and then this line right here, which is a line I got off of watching a YouTube video, which is a handy thing, which is it basically creates an integer called number of elements, and this function right here gets the number of elements that are in the specified array. So now when we do our for loop here, I don't have to specify how many elements there are in the array. Instead of specifying the number of elements that are in the array, sometimes you might not even know how many elements are in your array. You can have the compiler do it automatically for you, set that value to an integer, and then use the variable here that is set to the number of elements in your array. In this case, I already knew was 14, but I wanted to experiment using that function anyways. Okay, so now what we'll do is we'll show how these things are iterating. This is where it starts to get a little complicated, so just, bear with me here. Okay, so now I'm going to go on and explain the for loops that are being used to iterate through the array, and then set our other variables to be the values in the array in the correct order away from the last traded price. The first set of for loops here are being used to set our values below the last traded price. So what's going on here is the primary if statement in the for loop here is if array element is less than the last traded price. What that means is it's only going to perform this if we're on an array element that has a value less than the current value of the last price. Meaning that if it's landing on a value that's higher than the last traded price, it's gonna skip it and it's not gonna do this code right here. So we're only checking for values down when we have this right here. So these sets of for loops, we have 1, 2, 3, 4, 5 of them currently, or 6 of them. They're being used to do the downside iterations. For each of these nested if statements here, what's happening is it's going through the elements that are, in this case, that have values that are lower than the last traded price. And whichever one has the smallest difference from our last traded price is being set into this persistent variable in memory right here. Okay, and how I did it so that on the next iteration it doesn't go and get the same value is for every new iteration, for every new for loop we have here, I'm excluding the value of the variable that was saved in the previous one. So in this case, this for loop here will save the value of the closest study subgraph from the bottom to the last traded price. The next for loop here, difference down 1, is doing the same exact thing, except in this if statement, it's excluding the value of the value 0 down, which was saved in persistent memory. So we're excluding that one, and what that will allow it to do is basically go and get the next one down in the sequence, and that's the one it's going to settle on. Okay, so the if statement for the second one is if the current array element is less than the last traded price, meaning it's only looking for values that are less than the last traded price, lower than. And the second condition is the array element that we're currently on is not equal to value 0 down, meaning that the value of the current array element cannot be equal to this one right here, which is saved in persistent memory. If it is, it's going to skip it and iterate to the next one until it finds the array element that has the smallest difference to the last traded price, and then it will save it into this next one, okay? And so on and so forth, and we do that for every single value that we need to save. So in this case, I've done 1, 2, 3, 4, 5, 6 of them from the downside and 6 of them from the top side as well, okay? And this can be done as many times. Now, this method of iterating down and iterating up, I sort of built it from scratch. Maybe there's a better way. Probably there was. I was trying to find some research on it, but I was finding some really stuff that I really just couldn't understand. So I ended up just, slowly just hashing it out and slowly thinking about it, and eventually just settled with that, and it ended up working. Okay, so the next thing is when we go down here. Now this is important. This was sort of a debugging step I had to do, which is this. When there are no value down values that are lower than the last traded price, meaning that the market has moved so far down that all those study subgraphs are up, or maybe a few of them are up, and there's only maybe 1 or 2 values that are lower than the last traded price. What happens is this, for my debugging, the program sets our variables to incorrect numbers that are higher than the last price. And this is not what we want when we're iterating to find values lower than the last price. So this code is meant to set value down to 0 if we're getting a value that is above the last price. When these values are changed to 0, it will only trigger our third order block, which will submit a profit target with a fixed offset instead. And that was a request from Ryan, who asked me to make this study. So he basically said, if the market has moved so far down, and let's say I'm in a short position of 5 contracts and I just entered it, and there's only 2 subgraphs below my entry, you'll get the first target and the second target appear at the subgraphs, and then the next 3 will also appear, but they'll have fixed offsets away from the previous targets, okay? And those orders will only be sent when these values are 0. So this is part of the conditions that are required for the buy order conditions. Okay, so let's go on here. Now we have our order structures. Now for every single order, right now I've configured a total of 5 targets on the upside and 5 targets on the downside. For every single one of these targets, there are 3 order blocks that might trigger. And I'm going to describe to you how each one will be triggered. So this is the condition for the first target to be triggered. The first thing is input underscore target enabled needs to be 1, which means that our button on our chart, the ACS button, needs to be enabled. That's the first step for this study to even send any orders. So if this is not enabled like we showed before, the targets will not be sent. So that needs to be on. That's the first condition. So these targets are for a short position. First target for short position. The next condition is the position quantity is less than or equal to -1. So there has to be an existing short position. The next condition is we have a variable that is saved to the value of the prior position before the position quantity was changed. Bear with me here. Prior position is greater than the current position, meaning that we are in a short position and we were not in a short position before. What this does is it stops this order from being sent if we're doing anything else other than getting into a short position or adding to a short position, okay? And when we get to the buy order function, this one is the exact opposite. So for a buy order, it would be like this. Position is greater than or equal to 1, meaning that there is an existing long position, and the prior position quantity is less than the current position quantity, meaning that we have sent an order to increase our position quantity from flat to being long, or from being long to being more long. And this is a very important function that will only allow this order to be sent when the position quantity is increased for a long trade or decreased for a short trade, reduced. Okay, so in this case, this is the target orders for a short position. The next condition here is that value 0 down, which is going to be the value that we're going to set the target's price at. Value 0 down must not be equal to 0. The next condition is that value 0 down, meaning that the first value below the last traded price, plus 4 ticks, that's just an offset we were testing, is less than the average price. The reason why we put this offset here is because if you didn't, then you could result in this target being sent at a price that is pretty close to where you entered the trade. So if your average price is, I don't know, 3,000, and then the first value 0 down is at 2,999, which is 4 ticks in S&P 500 futures, then you're essentially going to have a target. Your first target's going to appear down 4 ticks below your entry, and probably you don't want that normally. I mean, 4 ticks is pretty small unless you're scalping. The next condition is that there must not be an order ID saved to this persistent variable, which is being used to save the variable for this order right here, target number 1. So S_T1 order ID will have a value populated to it when there has been a successful order submission, okay? So this is the first block. Now, here's the second block, the second important condition for the first target. What's different about this one is basically this is the condition here. So it's all the same except for this condition right here, which says if value 0 down plus 4 ticks in the market is greater than the average price, meaning that for whatever reason, value 0 down is not below our average price, or maybe it was, but now it isn't. And value 1 down, which is supposed to be the next level down in our iteration, plus 4 tick size in this case, is smaller than or less than the average price. What this is doing is it's basically saying this: if the value 0 in this case is too close to the average price, we're going to send the order at the next value down. But before sending the value at the next value down, we also need to make sure that there even is a next value down, because then we could result in sending an error in this order or something. So that's why these two statements are here, to prevent any error in this orders from happening, and also check if there is an actual next value down. If there's a next value down and if the statement comes true, then it's going to go ahead and submit this order block, and then this will be the first target for the short position. All right, if you guys are still with me, leave a like on the video. Then we have the third order block, and this one is just for an exception, which I will probably try to show you guys on the chart afterwards. And this is the exception: if value 0 down is equal to 0, meaning that it's been set to 0 using the code we previously showed you, then that means that there is no value there to reference. In that case, it's going to default to average price minus 10 ticks, in this case, a set fixed value. And I just want to make a quick note about using tick size. I did discuss this with Ryan very briefly, but Since we're using ticks here, what this does is it makes this study less adaptive to other markets, because certain markets, are thicker, they move less ticks. Certain markets are very thin. So if we're using fixed tick sizes here, that limits the study. That's why I'm not a fan of this. I prefer to use indicators that are volatility based. Take those values and use those as references for setting offsets, targets, and stops and all that. So if you guys watched my other video on my other system, that is an example of a system that tries as much as possible to avoid using fixed tick sizes for offsets. Instead, it uses volatility models to adapt to the volatility of the current market and the current market conditions. I just showed you guys the 3 blocks for the first target, and each target has these 3 blocks associated with it. So here we have second target, same old thing, except that for the second target for the short position, if you go ahead and look at the third case, the special case, if value 1 down is equal to 0, look at where the target price for this order gets set to. It gets set to target 1 price minus 10 times sc.tick size. So in order for the second target to go through, and that's something that I should mention, is that for each subsequent target to be sent, it is checking if there is a previous target live in the market. So if target 1 is not there, and you'll see that if you look at the if statements here, if target 1 is not there, then it's not going to submit target 2. And then when we get to target 3, if target 2 is not there, it's not going to submit target 3. And that's just the way it should be, okay? One thing is that for every additional target, we are using an SC trade order structure here and using this function get order by its order ID to call upon the order price of the previous order to basically make those checks. So on the very first order, remember that value X down plus a certain amount of ticks needed to be less than the average price. But for every subsequent order, we're not making reference to the average price anymore. Now we're making reference to the previous order in the sequence every time. So for example, if we look at the third target for the short position, the function has now changed to value 2 down plus 1 SC tick size is less than target 2's price, S underscore target 2 dot price 1, which is the price, the order price of target 2. Now, if you continue looking at the if statement, S underscore target 2 order ID must not be equal to 0, meaning that target 2 must be live in the market. It must have a value saved to memory that is not 0, okay? So it will not send target 3 if target 2 is not there. It goes through the sequence that way, okay? And of course, target 3's order ID must be 0, because if one of these other blocks gets triggered, it's going to set target 3 order ID to a number that's not 0. And of course, that's going to prevent these other blocks from submitting. That might just be a safety measure, but I put them in there. The more safety you have with these automated systems, the better it is, or the lower the risk that you get these erroneous orders getting submitted. So I definitely took some time to test this a lot before getting through it. Okay, so I'm going to try and show you if there's anything else that I need to show. Then there's just a few blocks here that are not really being used. They're only being used to reset the order IDs back to 0 once the orders have been filled or canceled. And this is being done for each and every order ID. So here, short target 1, short target 2, 3, 4, and 5. And then I was playing with this, which is when we reduce our position quantity, it cancels off certain orders. But again, this is something that was beta that I don't think is even necessary for the study. So we'll just skip that. And that's pretty much it, guys. Then we basically do the exact same thing, but for the buy side. So here's the iterations for now the top side values. So top side value 1, top side value 2, 3, 4, etc. And then we have, again, the code that is responsible for checking if those top side values are getting set to values that are lower than the last traded price or lower than the previous value in the sequence, then it sets them to 0. And when they're set to 0, it goes ahead and submits only the third order block, which has a fixed target offset. It ignores the first 2 order blocks here when these values get set to 0, because like I said, it means that there's no values to make reference to because the market has moved so far in one direction. All right. So then we have all our target orders again, same old thing, but all of the operators are reversed mostly, And so I definitely had to go in and do each of those manually, which did take some time. And then we have, again, our order blocks here for the order IDs for just resetting the order IDs when the orders are filled or canceled. And, this can also be used to modify the orders if we want to do that too. Like in my other study, I have auto order modification. I would put that basically in the block right here. Okay, and let's see if we can keep going here. And that's pretty much it, guys. That's the entire study. Let's just demonstrate it one last time. Make sure everything's turned on. Okay, so let's get into a long of 5 contracts. There we go. So in this case, it took a second for them to show up, but you saw the first target was submitted immediately, and then it basically saw that there was no other values there. And what we have here is the second target got submitted at the next highest value, which is 39,707, and then the next 3 targets are set in 10 tick offsets above that one because there's no other values here to make reference to, so it set them at 10 tick offsets just like that. All right, so let's go ahead and close this trade now. And let's do another example where we just get into, one contract at a time. So I'll short one contract. Okay, I'm short one contract, target appeared there. I'll short another one, target appeared there. I'll short another one, target appeared there. Again, it supports up to 5 targets. There's the 4th one, and get the 5th one in there. And there's the 5th one. There you go. All right. So I'll just change this to 5. And again, the trader might have a flat key or something to get out of these 5 contracts or whatever. But anyways, so this study automatically sets those targets to these standard deviation values or whatever values that are in the array. So hopefully, guys, you found this interesting. Let me know what you thought and leave all your comments down below. Thank you. Take care.